Greetings from space. And while that might sound a little weird because we are in Denver, our next presenter will be actually talking about sounds from Mars. As we listen to those sounds, Baptiste Chide from the Los Alamos National Laboratory evaluated years' worth of sounds from Mars, the Perseverance rover, and discovered some amazing sounds about the acoustics of the red planet. Baptiste?
Thank you, Larry. Thank you all for inviting me to listen together the sounds that we've recorded for the first time at the surface of Mars, thanks to the 2 microphones on board the Perseverance rover that landed last year on Mars. So yeah, this sound experience was provided by our amazing engineers, DJs at JPL and in the Los Alamos National Lab and in France under the authority of the Space French Agency that provided this rover and the ability to record the first audible sounds at the surface of Mars. So, well, I have to be honest, the solar system is a silent environment because for acoustic wave to propagate, we need an atmosphere. And we can count 4 terrestrial planets, only 4, with an atmosphere dense enough for acoustic wave to propagate. Of course, we have the Earth, and this conference shows that we use sounds in our daily life to characterize our environment. And, but if we look at the properties of these planets, we realize that the Earth doesn't have the atmosphere that is the most favorable for sound propagation. And for instance, if we consider the dense and hot atmosphere of Venus, the atmosphere couples very well with acoustic devices, and all the sounds are about 20 decibels higher on Venus than on the Earth. Another example is Titan, and thanks to its composition and its cold temperature, sounds are not attenuated so much, and sounds propagate farther than they can do on Earth. And we have Mars. Mars is maybe the least favorable planet for sound propagation, but still there is the soundscape to explore on Mars. And 1 year ago, we didn't have any audible sounds recorded at the surface of Mars, and since the landing of Perseverance last year, we can explore this soundscape, and for the first time we can do science with audible sounds from the surface of Mars. So here it is, the first Mars soundscape that we've recorded with the 2 microphones on board the NASA Perseverance rover. So we have 2 microphones, one here on top of the remote sensing mast, part of the SuperCam instrument, and one here on the deck of the rover that is designed to record many artificial sources generated by the rover. So Mars, there is little to record on Mars, let's say, and the main natural source that we record on Mars comes from the atmosphere. And here you have the first recording of the wind that we performed on Mars. Damon? So I hope that you were able to listen this rumble of the wind, this very low frequency signal from the wind. And by recording the wind, by recording the turbulence, we are studying the atmosphere at an unprecedented frequency range on Mars. And we also brought 2 sound sources with us on Mars. One is generated by the SuperCam laser-based instrument you see here on top of the mast, that ablates rock, that vaporizes rocks at the surface, and it generates a sonic boom that we can record with the microphone. It generates some sparks, some zapping sounds that we can record. We can listen now. So It generates high-frequency sounds that we use to infer some physical properties of the rock that we are sampling with SuperCam at the surface, which is a new information to characterize rocks at the surface of Mars. And the last sound source that we have on Mars is provided by the Ingenuity helicopter you see here that follows a Perseverance to explore the surface of Mars with us, and we were able to record the sound of the blades of Ingenuity from over more than 100 meters from the rover. And we use these characterized sound sources at the surface of Mars to infer and to confirm many surprising sound properties of the atmosphere of Mars. And especially, we evidenced a dispersion of the sound speed. The sound travel not the same speed for all the frequencies. And especially the high-frequency tones of the laser sparks travel about 10 meters per second faster than the low-frequency tones of the helicopter. So, for instance, if we had this conversation on Mars, hopefully not, you would receive the high-frequency tones of my voice a few milliseconds before you would receive the low-frequency tones, and that would lead to a kind of distortion that might be difficult to have this talk on Mars. And this is due to the unique properties of the atmosphere of Mars made of carbon dioxide and a very low pressure. Two other very surprising sound propagation properties of Mars is that because of the low pressure at the surface of Mars, there is a low coupling between the atmosphere and some acoustic devices that makes the sound about 20 decibels lower on Mars than they can be on Earth. Mars is actually a very quiet planet. And also because of carbon dioxide and its unique vibrational properties and its large viscosity, then sounds are drastically attenuated with distance compared to what they are on Earth, and especially in the high-frequency domain, which leads that on Mars we have almost no high-frequency sounds because of carbon dioxide. So these are the main properties of sound propagation that we have highlighted with the SuperCam and the Perseverance microphone. And hopefully the future Mars astronauts will have some pressurized helmets to communicate, also to survive on Mars. But here we've shown that the use of acoustics initiates a new field for planetary exploration to explore the atmospheres in our solar system in an unprecedented and very high frequency new range. And thank you very much, and I'll take any question.
Thank you. This was very fun. Actually, when he was playing this earlier for us, we thought somebody was moving furniture. The vibration was so low. You talked about the different planets, Venus, Titan. If we could talk on Venus, would we experience that same kind of delay that you talked about, where you hear the high frequencies first and then hear the low frequencies?
So this dispersion of sound speed is a combination of two factors: carbon dioxide. So we have also a carbon dioxide-rich atmosphere on Venus, but the other factor is pressure. And we experience this dispersion in the audible range on Mars because of the low pressure. On Venus, the transition frequency will be higher and out of the audible range. So we would experience this dispersion, but higher in frequency, and our voices don't go that far.
Are there any other planets or moons in the solar system that might lend itself to this kind of acoustic research?
Acoustic studies would be super useful on Venus, as you said, also on Titan. Titan is a fantastic world for acoustics because sound propagation properties are very good. Sounds travel very far, and with the low attenuation and the good coupling. And we have a lot of sound sources on Titan because of meteorological cycle of methane and so on. So Titan is definitely the most exciting world for acoustic studies.
When are you going?
Sorry?
When are you going?
Oh, on Titan, I don't want to go there. I don't want to go there. 90 Kelvin at the surface. That's a kind of a harsh environment.
Let's take some questions from the room.
Yeah, so do the seasons on Mars impact the sound in any way?
Sure. So, on Mars we have 4 distinct seasons, as we have on Earth. And the surprising thing about the seasonal cycle on Mars is that the pressure varies a lot, about 20% between summer and winter because of carbon dioxide that condensated to the polar caps. And so the pressure changes drastically. And so the sound volume changes as well because the acoustic impedance changes as function of the season. And so summer on Mars are louder than winters, for instance.
Okay, cool. And what kind of information does this tell us about Martian weather, if any?
So yes, we're studying we are recording and studying the atmosphere in the audible range, so up to 20,000 hertz samples per second, and it tells us, as Stephen mentioned just before, we are studying the atmosphere at very short time scales, and so we can study the turbulence. And by studying the turbulence, we know more about the climate, about the energy exchanges between the atmosphere and the surface. And this is a huge problematic on Mars. For instance, the climate on Mars is controlled by dust, and we don't really know how dust is lifted from the surface. And new insights into the turbulence might help us understand how dust is lifted from the surface into the atmosphere.
Great. And what are your future directions of research? Are there other questions about the Martian atmosphere that new recordings might answer?
Sure. So now it's been 1 year that we are studying the Mars soundscape. So now we want to study it as function of the season. So we experience 2 seasons now on Mars, but we want a full Martian year to study the acoustic properties as function of the year. But Mars is not the only planet to perform acoustic studies, and definitely I hope that now the future Mars missions will carry some microphones, but also future Venus and Titan missions, and especially the NASA Dragonfly missions is sending a drone to Titan in the 2030s, and it will carry at least one microphone to record this amazing soundscape in Titan.
Question from the room.
You said that the temperature is very different between seasons and Mars. So do you think it's easier to measure temperature with acoustics or do acoustical tomography on Mars than in the ocean on Earth?
Yeah, that's a great question. Actually, we already measure the temperature on Mars with traditional temperature sensors, and but we use the sound sources that we have, especially the laser sparks, to provide us, to give us an active acoustic experiment, and therefore measure the sound speed and the acoustic temperature. And we realized that it's another way to measure acoustic temperature, and also we catch large temperature fluctuations that are not catched by other traditional instruments because of all the advantages of acoustics. So this is a new way actually to study the atmosphere, and we can do the same for the winds. And when we are recording the winds, we are catching very rapid fluctuation of the wind that are not catched by other meteorological instruments. So this is really the added value of using acoustics on Mars.
I think we're good.
Thank
Okay.
you.
Thank you. The wind sounds so pleasing and so relaxing. You know, might be a nice bedtime noise.
Actually, we need very good headphones to hear it was perfect, but we need a very good speaker or very good headphones because it's very low in frequency, and if you use the speaker of your computer, you won't feel the rumble of the wind.
So you're saying it's not going to be on Spotify anytime soon? Okay. I just wanted to check. Thank you so much. And thanks to all of you for joining us for this 11 o'clock session. We have one more session at 1 p.m. Mountain Time. We're going to be talking about the different acoustical research into our health and mental well-being, as well as an important talk on the perception of voices in different regions and how they impact how people react to those voices. So join us then. A reminder, if you've missed this one or you missed the 9:30, we will have recordings later in the week, so you didn't really miss anything at all. But thanks for joining us.